Okay, so let's start. I don't think that anyone else would be joining this meeting anymore. So, for this is the trial class for your May 2024 is physics batch, and this will be an year-long batch, and everything will be done in details. Those of you who haven't um, understood all of the concepts of your IGCSEs are not that much of a big deal. Like, it won't be a big deal for this class because we would start from the basics. As I'm assuming that this is like a fresh batch for May 2023, the 24. I mean, you guys haven't actually get any hold about your A levels yet. Right, you guys don't have any ideas on how many units you're going to study, how many concepts that we'll have to understand in this class, and what are the different requirements that you are supposed to have in this basics. So usually people take physics from the two backgrounds. First one is for the medical fields and one for the engineering fields or pilots, right? So for engineering and pilots, the subject requirement is kind of same, that maths and physics and chemistry in some places are required. But for medical, they have physics, chemistry, and bio as a compulsory, but maths as an like, optional part. So the problem with maths is that maths is a very essential part for your physics unit one. Physics unit one is like 80% of physics unit one will be entirely based on your maths unit. There's a one unit in maths, M1, and your entire physics unit one will be like based on the basics of M1. So those of you who haven't who is planning to sit for the medical exams or is not planning to take the maths in A levels, that will kind of not be an important problem, but you guys will have to do some extra classes because of the lack of knowledge of the M1, right? We can provide the extra classes in this course also for those of you who doesn't have the M1 in your A-levels AS. And those of you who are actually going to take, like they are considering taking um, maths in A-levels, then you guys should actually consider taking P1, P2, and M1 in your AS because taking M1 would help you a lot in your physics A unit 1, AS unit 1. For A2, maths are not that much of a big deal. For physics A2 doesn't have any that much of help from maths. Only AS is kind of dependent on one unit of maths. So whatever, as I was saying that as this AS will have three units. Your entire A levels will be composed of 6 units. Unit 1, 2, 3, 4, 5, 6. Unit 1, 2, 3 will be on your AS. Unit 4, 5, 6 will be on your A2. Unit 1, 2, 3 like 1 and 2 are based on theory and with understanding concepts and everything. Unit 3 is based on experimental practical stuff. Now, in your Excel part, we do not have any lab and facilities to conduct the experiment in real life. So in your exams also, you will not be asked to perform a real life experiment. You guys will be just asked about that what kind of questions supposed to be in a certain kind of experiment if we were to like, conduct the experiment in our present time. So just theoretical questions, nothing else. And those of like all the possible questions and all the possible answers we will all talk about when we start our unit three. So for the time being, let's first get introduced with your A levels specification. So I'll just turn off my screen and we'll start doing the I'll write on different screen and my every classes are recorded on a different device. So I'll just turn off the screen and start representing my screen so that you can understand that what kind of things I will be asked in your entire A-levels. So if there is any question, then you guys can turn on your mic and then ask, or you can also use the comments or messages for the questions. I hope everyone can see my screen, right? Is there anyone not able to see the screen? I know this is an online class, but it would be really helpful if you guys would communicate a little bit. So I think, I mean, as anyone is not responding, I'm assuming that everyone is able to see the screen. This is the specification for your AS physics. There will be like three units, as I've already stated. Unit one, and this is still unit one, unit two, and this is unit three. In unit three, you will be asked eight core practicals. These four practicals are not the concepts from any different units. These four practicals are taken from your unit one concepts. Like when we will be completing our unit one, we would complete all these concepts also, but for unit three, we have to do a special extra classes focusing on experimental type questions, right? So when we start unit 3, we are not supposed to start any new concept, or we will not leave these concepts for unit 3 in our unit 1 explanation classes. We will do all these in our unit 1 and unit 2 regular classes. And again, at the end of the syllabus for unit 3, we will again redo these core practicals and give a proper explanation, detailed explanation for every 8 of the core practicals. So for the divisions of these core practicals are like core practical 1 is from unit 1. Core practical 1, sorry, 2 is again from unit 1. Core practical 3 is again from unit 1. This is again from unit 1. Like four of the core practicals are from unit 1, and the last four of the core practicals are from unit 2. So let's first get introduced with unit 1 and unit 2 concepts. There are like in your physics book, is physics book for like endorsed by the edexcel student book 1 has four topics. Topic 1 and topic 2 will be considered under unit 1, and topic 3, topic 4 will be considered under unit 2. Topic 1 is movement of particles, and topic 2 is materials. The topic 1 has several subtopics, and those subtopics again have several mini concepts that we need to understand. For example, these are physical quantities and units, kinematics, vectors, projectiles, forces, and work, energy, power, momentum, and moment. These six subtopics are exactly like actually taken from your topic one of unit one. All these six subtopics fall under that movement of particles concept, and only topic seven, which is also like it also has like two subtopics. You can clearly see fluids and solid materials. These fall under the second topic of your student book or topic two of your student book, which is materials. So for the A's, the things that you already know, I'm assuming, is that speed, velocity, acceleration. We obviously are going to explain this in A levels because this time we have to understand things with a much deeper concept. But other than that, we do have some kind of idea that what is speed, velocity, and acceleration. The constant acceleration equations. We did study two of the constant acceleration equations in our IGCSEs, but now we will have to use four of the equations. A little bit about basics of the graph. I'm assuming that we do have certain basics about graphs. Sorry. We do have some basics about graphs, and for vectors, we actually didn't do anything about vectors. Vectors is an entirely new topic for your AS. Right, this is a new topic. We haven't studied anything about vector. Vectors are not specifically talking about vector quantities. These are entirely new thing. And again, for projectile, this is again a new thing. For forces, we did study Newton's law of forces in your IGCSEs, but in this time it will go into a much more depth. So we did study, like we have some kind of ideas of the three Newton's law. And I'm not sure that if everyone is aware of all the types of forces that we are going to study in your AS. So I think option like types of forces is not something you did, so I'm gonna not place a tick beside it. Basic calculation is basically the force equation involving F equals to ma. We did calculations involving this equation, F equals to ma. So I'm assuming that we did some basic calculations for forces. The difference between N1 and N3. N1 is Newton's first law and N3 is Newton's third law. Now there are similarities between third law and first law. So we will explain that, but we haven't actually seen any of these things in your IGCSEs. So, after this, what everything that is coming into this part, work, energy, power, moment, momentum, all the things you did, but this time it will be associated with angles. Not everything will start acting from a linear vertical plane or horizontal plane. This time they will create angles, they will have to create components and everything. So I'm considering that after topic 5, from topic 6 to topic 7 and everything beyond this, we haven't touched anything in your IGCS. So everything will be new for this part. They will be have densities, pressure, upthrust, and floating different liquids, and then turbulent laminar viscosity, Stokes law, and then elastic and plastic deformations. We did like have like second chapter in your IGCSEs cleared all these concepts from your IGCSEs, but this time everything will go into a very much detailed view. So I'm assuming that we do not have any idea about the materials topic. And again, from property unit 2, we only have idea about these properties of waves, that is, what is frequency, time period, wavelength, and all. Other than that, everything is new, like diffraction, critical angle, interference, superposition, wind instrument, string instrument, ultrasound, polarization, then quantum physics. This is entirely new. For your electricity also, I think just the IV graph for filament bulk that we did in your IGCSEs, that's the only thing that will be relevant to your AS electricity. Other than that, everything is again going to be new for this AS. Right? Nothing that you did before in your IGCSEs. And obviously, as I've explained, next is core practicals. Unit 3. Unit 3 is again a part of the Unit 1 and Unit 2. Nothing new to study over here. So up to this, anyone have any problem about how are we going to finish the classes and what kind of things are we supposed to take in the classes? So if everything is clear in your extra class, like this is a free trial class, I will not just end the class by explaining the syllabus. I will start with the first topic, that is physical quantities and units. And I will finish this entire concept, like base quantities, derived quantities, then converting the units to base units, and do the dot multiplications. Right. And from our next class, that will basically start from 3rd July or 4th July. We will start with our second topic, kinematics. So let's start with our physical quantities. Yes, you will get recordings of each class, and let me just write it down over here. That what are the things that you guys can expect from this class? So the first thing is that we will take 3 weekly classes, mostly on Sunday, Tuesday, and Thursday. The class timings will be around 8 p.m. Like 8 p.m. to 9:30. Sometimes it might take few more minutes. Like it might also end at 10 p.m. So there will be like 3 weekly classes, Sunday, Tuesday, and Thursday, all on 8 p.m. Obviously, Bangladesh time. For Rashli, I guess it will be on like 7:30. Okay. So And in your classes, you will get class recordings. Like this class is also being recorded, so everyone will get the class recording. And including this class recording, you guys will get the class slides. Everything that I will write on the screen, I refer to that as class slides. So these class slides will also be uploaded in your Google Classroom, and including this, your notes. Like there are a few notes that you will get from your uh, on each topic. Like notes will be with like in PDF version. Let me just show this to you with how the notes will be. I want to turn on my screen. And this is the previous batch for your AS. And this is how the notes are supposed to do. Right. This will be like a PDF notes that you guys can go through this when you are going to revise a chapter or a concept. All the class sites will be also added to this. Like you can see in this part, they do get class videos, class notes, and class slides. So this is how the class slides will be. Everything that I write on the other device will be added on this classroom again. The concepts that we study today is quantities and units. Okay, this is the concept that we'll study today entirely. So that I also have a PDF separately for this topic. So this will be also added in your classroom. So this is how your chapter notes or PDFs would be. And this is your going to be like class slides with everything that I will write on the class on the screen that will be referred to your class slides, and the class video recording will also be added in the classroom. So just turn off the screen and start my screen from the other device. Okay, so you will have class slides. You will get slides, notes, and recordings. So, and including this, you will get worksheets and like mini exams after we are complete, after like we are done with certain amount of topics. I will take monthly exams and worksheets. I will first give the worksheet as an example, like as an homework, and then you guys have to submit those in a certain amount of time, and I will solve the worksheets in the classes again. So anything you will not understand in the classes will be explained in the worksheet solving classes. And worksheet solving classes will be taken on the regular classes, like Sunday, Tuesday, Thursday. And for tutorial hours are not included in the 3 days, like the three class days. Tutorial hours are like extra classes that will be provided. I'm usually free for tutorial hours, usually free on Thursday in the morning from 9 a.m. to like 12 p.m. So you guys can knock me during this time. If you guys have any problem in any of the topic we are doing in the class during these 3 hours, we can solve any of the problems that you're facing, either from the class lecture, class slides, any of the concepts that we're not clear enough, and or any of the questions that appear in your worksheets or exam. You have any questions about it, you can solve those problems in that tutorial hour. Okay, so let's start for our explanation. There's nothing else that is need to be explained how our classes will be conducted. So we are first going to start with how things are actually divided in this world. Everything are divided or categorized into two headings. The first one is quality, and the other one is quantity. Quality are those things that cannot be expressed in terms of numbers. For example, quality is something like if I have a headache, I cannot explain that how much headache I have. I can only express that in words that I have extreme headache, I have moderate headache, or I have at least like a bearable headache. But I cannot give you exact number that how much headache do I have. Right, so these kind of quantities, this kind of things are referred to be quality. Those kind of thing that doesn't can be expressed in terms of number are referred to as quality. For example, how smooth a piece of cloth is, or how I have a certain amount of pain in my body, like how much pain am I feeling over there. I cannot express those things in terms of numbers. So anything that cannot be expressed in terms of number are referred to be under the quality heading. So anything that cannot be expressed in terms of number. Now for quantity, everything that can be expressed in terms of number are referred to as quantity. For example, speed, velocity, distance. You can express distance in terms of number, right? For example, point A is 5 meters away from point B. Right, I can give you a visual representation. Like point A is 5 meters away from point B. So you can clearly explain that how much distance is there between the two given points. So distance can be referred to be under a, like can be referred to be as a quantity because it has the numerical value. So any kind of thing that can be expressed in using numerical value are referred to as quantity. So this time you will have numerical values. Now every uh, quantities are then like further categorized. In your physics, we are just going to work with quantities, not with quality. Right? Quality is a thing that is beyond our explanations. So we cannot use quality in your physics stuff. We are just going to focus on quantities. So for quantities, they are then further categorized into two units. First one is that are they vector or scalar? And again, second one, are they base or derived? Okay, first one is a vector or scalar, and this one, if are they base or derived. I think from your IGCSEs, we have already aware that we're already aware of the fact that what vector and scalar is. Can anyone like give me the definitions for vector and scalar? I think we all did memorize this for our IGCSEs exam. The basic definition for vector and scalar. You guys can obviously use the comments or like messages option in this meet. Anyone have any idea what vector and scalar is? Well, I think you guys are all very shy to reply, but I know that for a fact that you guys already know the definitions at least for vector and scalar quantities. For vectors, the definition was every quantity that has both magnitude and direction, and for scalar, every quantity that has their only magnitude, no vector quantities. For base and derived, these are like the new concepts that you will be facing in your A levels. We did not receive any knowledge for base and derived quantities in your IGCSEs. These are new things to work with. So for the time being, we know that quantities are anything that has their own numerical values, and quantities are further categorized into vector, scalar, or based and derived. Right. So we first explain that what is based or derived quantities. The best example for base quantities is that distance. Right? You do not need any other quantities help to find out the value for distance. You can usually take a meter ruler or any measuring device to find out the distance between any two given points. Right? So all the quantities that do not rely on other quantities are referred to be or like to be a base quantity. For example, speed. The equation for speed is distance divided by time. In order to calculate speed, this time you have to first measure the distance, measure the time, use those two quantities to like use their two values and input the values in this equation. And then finally you can find out the value for speed, right? Other than that, you cannot actually find speed without finding the value for distance or time taken. You cannot calculate the magnitude for speed or the value for speed. So to calculate speed, you have to find out the value for distance and time, which means that speed kind of relays on distance and time. Speed depends on distance and time. These type of quantities like speed are referred to as derived quantities. Okay, so the basic definition for base quantities would be like simple that any quantity that does not depend on other quantities or any quantity that can be directly measured are referred to as base quantities. So let me just write it down. Now, out of all the quantities that you will came across in your physics career, only seven quantities are an example for base quantities. Other than those seven quantities, everything will be a derived quantity. So the least for those seven quantities are time, mass, time, mass, density, so distance, temperature, current, moles we did this kind of mole calculation in your chemistry, right? This is also referred to be as a quantity, so that's why we also added that in the list of base quantities in physics. And lastly, light intensity, or you can also consider that as luminosity. Now, out of these seven, we have already came across time, mass, distance, temperature, current, and moles. Luminosity is not involved in your AS. After AS, like in your course, in university courses like Physics 105 or in higher courses, you will came across this seven base quantity luminosity. Up to this point, you just have to understand the fact that only these seven quantities are base quantities. Only these seven quantities can be directly measured using a measuring instrument. They do not have any they do not have any formula to be calculated in order to find out their values, or these quantities do not depend on any of the other quantity. These are the only seven quantities that are referred to be under the base quantities. And other than that, all of the quantity that you will come across in your AS, A2 or university level, everything will be under derived quantity. For example, speed over here, you can clearly see this example. Speed over here is an example for derived quantity because it depends on both distance and time. If you have a focus on velocity, it again depends on displacement and time. Acceleration, it depends on velocity and time, right? All the quantities that you have studied so far, other than these seven, everything is a derived quantity because all these have their formula. You can differentiate base quantity from derived quantity by focusing on that if that certain quantity has its own formula or not. If a certain quantity has its own formula, then that will be a derived quantity. If the certain quantity does not have its own formula, then it will be the base quantity. Right. So, for example, if I have to give an example for kinetic energy, this is half mv square. Right. This kinetic energy depends on the mass of the particle, the velocity of the particle. So Ke depends on two quantities, mass and velocity. So therefore Ke is a derived quantity. Now the main A levels part depends on their units. Like so far we know that every quantity has their own numerical value that is referred to as the magnitude and also their units. Now these derived quantities sometimes have their own derived units also. And we have to somehow break down that unit into its base unit. So for example, let's start with, let me just compare that why base units and SI units are different. I think we're aware of the fact that what SI unit is. SI unit is that out of all the possible units, one unit is picked up and to be used for international purposes. Or when we are supposed to work in a very high model place, we are going to use those units. For example, distance can be measured in centimeter, meter, kilometer, decimeter, right? All these units can be used for the calculations of distance, but in your SI unit, only meter is used. So in the international level, you will always represent distance using the meter unit, M unit. So over here, I was trying to explain that how can you differentiate between base unit and SI unit. For example, if you focus on the fact acceleration, acceleration is a very simple quantity because its base unit and SI unit are both same. That is meter per second square. Meter per second square means that over here the velocity change will depend on 1 second. Like how the velocity would change after every second will give you the value for acceleration. Right now, this time using this base SI unit, I can clearly understand that the SI unit can be broken down as m slash s into 1 over s. Right? That's how you got m slash s square. Now, this clearly represents that velocity was in the equation and 1 over s, or maybe the quantity that is being involved, is time. It indicates that from the just the units, you got the idea that what kind of quantities were associated with the actual quantity, like with the actual acceleration. Acceleration is associated with velocity and time. We got that from just the equation, from just the quantities unit. Now, on the other hand, if you work with force, the SI unit for force is newtons, based on the scientist who invented this. Now, the problem over here is that Newton doesn't give you any idea that what kind of quantities are involved in this force equation. And force depends on which kind of quantities. We don't get any idea from the SI unit. So this time we have to break down the SI unit into its base unit. We can do the conversion by using the using the equation for the force. The equation for force was F equals to ma. The mass has its unit kg, acceleration has its unit meter per second square. Right, so this is the base unit and the SI unit was Newton. So let me just highlight this. This is the SI unit and kg, meter per second square, is the base unit. So just like this, you will have to like in your exam, unit 1 exams, and sometimes in your unit 2 exams also, they would ask you to find out the base unit for quantity like voltage, for a quantity like resistors. Okay, resistance. This kind of quantities, like voltage has the unit volt V, resistance has the unit ohms, right? Ohms is just as a unique sign, this like with this kind of sign, this kind of symbol. Now you might have to represent these SI units to its base unit. So let's start with few easy concepts. For example, watt. Watt is the unit for power, right? Now, power has its equation, energy divided by time, right? Power equals to energy by time. So power equals to energy by time. Again, watt is named after the scientist who invented power, and from watt we cannot understand that what kind of quantities are involved in the equation or what kind of quantities the power depends on. So that's why we have to find out the base unit format of watt. Now, energy is broken down into joules over time. Time is seconds. Now, energy is again a further derived quantity. Energy has its own equation, like has its own quantity name, unit name, that is joules, and joules further again depends on something else. So you have to break down energy also, like break down joules also in terms of its base unit, and finally use that in your calculation for power. So if you have to work with energy, you can work with work done. Work is a form of energy. Energy, there are three types of energy: work done, kinetic energy, and gravitational potential energy. Right? They all will give you the same unit. Just work with work done for the time being. Work done is force into distance. Force was kg meter per second square into m. We can write kg meter per second square as kgm divided by a square into m, which can be further simplified as kg meter square slash s square, right? Because the two meters get multiplied together, so we get meter square. So you can use this. This is the SI unit for joules. So you can use these and input that into the calculation for power. So in terms of writing joules, now we can write kg meter square per second square divided by second. Now this time we can clearly see that the numerator is in divided format. When the numerator is in divided format, it is always recommended that you write the denominator in a separate version. So everything will look like kg meter square divided by second square into 1 over second. This second that I have written separately from the overall equation, it represents the denominator. This second represents the second on the denominator, and this second square is situated over here. Right, so now if you just multiply, like simplify, you can clearly see that the 3 seconds will get multiplied together, and it will be kg meter square divided by s cube, or you can also write in index format or in division format. If you write this in division format, it will be meter square slash s cube. If you want to write this on the index format, then it will be kg meter square. Anything on the denominator, when you pull that up on the numerator, sign changes. The sign of its power changes. Like for example, over here the denominator is s cube, and over here the denominator is pulled up to numerator position, and that's how you have s power minus 3. Is there any problem up to this, that how can we convert the power watt into its base unit? Both kg meter square slash s cube or kg meter square s power minus 3 represent the same thing. Is there any problem up to this?
No, there is no problem.
Okay. So if there is no problem, I will then explain that how as I've said that there are three types of energy: kinetic energy, gravitational potential energy, and work done. All of these are referred to be one kind of energy. For example, they have different equations. Work done has the equation force into displacement. Then kinetic energy has its own different equation. Gravitational potential energy again has its own different equation. So let me just copy this, and this was the calculation for work done that we refer to be as a format of energy. Another format of energy is kinetic energy. Kinetic energy has its equation half mv square. Now, half doesn't play an important role. It is just a number, right? Numbers do not have their own units. We are just going to focus on M and V. So mass has its own unit kg and velocity has its unit meter per second square, which can be broken down and written as M divided by S square. And again, if you calculate the square part, it becomes kg into meter square divided by second square, which can be further written down as kg meter square slash second square. And this was exactly the unit for work done, right? So we got the final unit same. The SI unit is same for kinetic energy and work done, which means that both of these quantities can be categorized under the quantity energy. Right. And similar to this, we can do the same calculations for gravitational potential energy also. Now, for gravitational potential energy, the equation was mgh. Mass is kg. This g over here represents gravitational acceleration, not any other thing, not any like gravitational field strength. This just represents gravitational acceleration. Now again, gravitational acceleration is just a fancy word for acceleration. The unit for gravitational acceleration will just be the same to that of acceleration, which is meter per second square. So over here will be meter per second square multiplied with meter. Height is a form of distance and unit for height is going to be just meter. So again, if you just, write this separately, everything will look like kg meter per second square into meter. And this becomes kg into meter square over second square. And finally, you can write kg meter square over second square. Again, the same SI unit for all these three quantities, which means that gravitational potential energy, kinetic energy, or work done, they all are three parts of energy or can be categorized under one quantity because they have the same SI unit and also the base unit. They all have the unit as joules and they all have the base unit as kg meter square per second square. So this is how you're supposed to convert any kind of base unit, so a derived unit in terms of its base unit. So now I think you have your camera with you at least, like phone with you, so that you guys can take a picture of your working. I will give you a classwork. In every class, we will provide or we will give classworks so that we can see that you guys are following with the class or not. So just a mini classwork for the time being. We have to do a conversion from the SI unit to base unit for power. No, need for power, you will do that for pressure. I will provide the equation. You just have to convert the SI unit to its base unit. Pressure equals to force over area. This is one of the classwork. Another one would be pressure, force, and area. Voltage equals to power over current. Now let me remind you the SI unit, so base unit for power was kg meter square per second cube. Current is a base unit, its unit is ampere only, and the SI unit for voltage is V. The SI unit for pressure is pascals. Now convert these SI units to base units and take a picture of your working, then send it to me in my WhatsApp. Pooja, are you doing the calculations? Are you facing any problem?
ভোল্টেজটাতে সমস্যা হচ্ছে একটু, প্রেশার পেয়েছি।
Then send me a picture for your pressure working, please.
ওকে। Is it all right?
Newton per meter square. Yeah, that's correct. Newton meter square. This is Newton and area was meter square. So you can write it down as Newton slash meter square or in terms of indexes. That's fine. Now for voltage, the SI unit is voltage. The base unit would be power is further broken down into kg meter square divided by second cube, right? So you can write it down as kg meter square divided by second cube further divided by current. Now this time you can clearly see again that the numerator is in divided format. So you have to write it down as kg meter square second cube. Like I'm just writing the numerator as a separate version and the denominator as a separate version. And this would just look like if you just simply multiply all the numerators together and all the denominators together, it will look like kg meter square multiplied with 1 divided by a into second cube. And finally, it will look like kg meter square divided by ampere second cube, or you can further write it down in terms of index as meter square slash a s cube, or as an index format kg meter square a power minus 1 s power minus 3. Is this clear for the calculations for voltage?
Yes, understood.
Okay. Then after this was everything that we kind of need to know for your difference between base quantity and derived quantity. You have to understand that which quantity is base and which quantity is derived. I have explained that already, that any quantity has their own equation is referred to be under the derived quantity, and any quantity that does not have its own equation is referred to be under the base quantity. Now, the units for base quantity cannot be broken down into further simplification, but in most cases, the derived quantities have their own units, separate units, and those units can be broken down into its simpler versions. And that's what we did in these calculations, right? We did the calculation for watt, joules, and pascals and voltage. So from this part, we move to the next category, that is vector and scalar. Just give me 1 minute. Wait. Oh, sorry. So we are going to move to vector and scalar quantities. The basic definition for vectors would be just any quantity that has its own direction and magnitude. Let's start with first vector. Sorry, let's start with first velocity. I mean, it's a first scalar that would be like easier to explain. Then we'll move to vector quantities. So scalar quantities are quantities that have only magnitude. Now, magnitude is a very fancy word. The basic easy word for magnitude is going to be the numerical value. For example, distance, you get two things for distance, that is 5 meters. Over here, the 5 is the numerical value, or in terms of physics, that is referred to be as the magnitude of the quantity. And meter, this one is going to be the unit of the quantity. So every quantity has its own separate unit, and depending on any situation, the magnitude might change. So for scalar quantities, they have only magnitude. Unit is a basic format for every quantity. Doesn't matter if they are scalar or vector, base or derived, every quantity will have its own unit. But depending on vector and scalar, some quantities will have magnitude only, some quantities will have both magnitude and direction. And the quantities that have both magnitude and direction are referred to be under the concept of vector quantities. So for vectors, quantities that have both direction and magnitude. For example, if I have to express, then this will be the best example, displacement 5 meter towards north. So this time, in addition with its magnitude, in addition with its meter, like unit, and this time it has a new category, that is direction. North over here represents the direction of the quantity vector. So you can clearly see that distance was categorized under the scalar quantity because it has only magnitude. On the other hand, displacement is categorized under the vector quantity because it has both magnitude and direction, right? So this is how you are supposed to differentiate that which quantity is going to be scalar or vector. Now again, how do you know that if a certain quantity has its own direction or not? For example, if I just give you a random quantity like velocity, for the time being, just assume that you have no idea what velocity is, but you're only given the equation of velocity, and there is no value of anything is also given for the velocity. So you cannot actually explain or understand that if velocity is going to be a vector or scalar quantity. For those kind of situations, we do one calculation, that is dot multiplication. Dot multiplication is a very simple calculation that helps you to understand that if a certain quantity is a vector or scalar. Using this dot multiplication, it makes it easier for you that you do not need to memorize all the quantities in physics anymore. You just have to memorize three basic quantities. Let me just add few papers. Right, the three basic quantities, or the three scalar quantities, you just have to remember this. Two scalar and one vector maybe. Right, out of all the quantities, you just have to remember these, that mass is a scalar quantity, distance is a scalar quantity, time is a scalar quantity, and displacement is a vector quantity. If you remember these four only, you can derive these four and find out any kind of quantity that the quantity is vector or scalar. So for dot multiplication, there is one assumption. The first assumption is that all the scalar quantities are assigned with plus sign, and all the vector quantities are assigned with minus sign. Like we will represent any vector quantity in your calculation with minus and any scalar quantity in your calculation with plus. Just give me 1 minute. Why? Then just fell down. So let's start with simple quantities. For example, I'm not sure that if speed is a scalar or vector. So I'm first going to write the equation for speed. Like in order to identify using like any quantity is a vector or scalar using dot multiplication, you have to have the equation for that quantity. Distance over time. So over here, I'm not aware that what kind of quantity speed is. So I will just use distance, like by memorizing knowledge. So distance is a scalar. So according to your dot multiplication assumption, every scalar is represented by plus and every scalar is again represented by plus. Both distance and time are scalar quantities over here. So we represented all the quantities using the plus sign. So you just do the simple calculations. In your calculator, you can just divide plus 1 divided by plus 1. Like if you have very little knowledge about algebra, then you can use your calculations like this, the calculator like this, and the final one will be plus 1. The final answer on your calculator will be plus 1, indicating that the final sign for speed is plus, which means that the final sign for speed is plus, indicating that it is a scalar quantity. So we can refer to these as scalar. Or the rules, basic algebra rules are again the same. If you multiply plus with plus or divide plus with plus, you end up with a plus. Right? If you multiply or divide plus with minus, you end up with minus. If you multiply or divide minus with minus, you end up with plus. Right? This is a basic rules for algebra. So this is how you can find out that scalar speed is a scalar quantity. Just like that, you can do the same calculation again for velocity. The equation for velocity was velocity equals to displacement by time. Now, from our basic memorizing knowledge, we know for a fact that displacement is a vector quantity. And according to your dot multiplication assumption, all vector quantities are referred with or represented with minus sign. So you will have minus over here and time at the base. And if you do the calculation, minus divided by plus from your basic algebra knowledge, you know it will be minus. So vector over here is vector ends up with a minus sign, indicating that vector is a, sorry, velocity is a vector quantity. Realistic. Velocity end up with a minus sign, indicating that velocity is a vector quantity. Again, let's do another calculation for your acceleration. Acceleration is just change in velocity over time. Now, change in velocity is again a velocity, right? And velocities are vectors, so they will be represented by minus sign. Time is positive because it was scalar, and then again, the final sign for acceleration is minus, indicating it is again a vector quantity. So now you have to do one calculation for F equals to ma. Find out that if force is a vector or scalar using the dot multiplication. Then for GPE, the equation is mgh. Over here, the h is just um, displacement. Okay, in gravitational potential energy, we are not working with just distance. The gravitational potential energy works with distance from origin, which basically means displacement. So over here, this is displacement. This g is gravitational acceleration. And m is mass, right? So you have to find out that if GPE and force, if these are vector or scalar quantities. Please do the calculation just like I did and click a picture of your work and send it to me in the WhatsApp.
Are vectors negative, right?
Yes, vectors are negative and scalars are positive. For your force, the final sign is minus, then it becomes vector, right?
Vectors are negative.
Right, vectors are negative, scalars
Uh,
are positive.
তাহলে দুটো নেগেটিভ। হ্যাঁ,
So
সরি, the
GPE,
second second one will be scalar. It will
second one will be
interchange. It
scalar,
will
right?
interchange.
Yes. Both of them, uh, gravitational acceleration and displacement are vectors. So they add together, so they multiply together, and the final product is plus, minus, minus. If you focus on the minus with the two negative signs and multiply those, you end up with plus and plus. And the final sign is plus, indicating that GPE is scalar. And over here, mass was scalar, acceleration was vector. So the final sign is again vector. So can you do another calculation for kinetic energy? Half mv square, and another one for power. P equals to IV. I think it would be tough for you to do this now because we are not aware that what current and voltage is. So let's just start with energy over time. So find out that if kinetic energy and power are vector or scalar.
Could you show the table?
Sorry, maybe you send me the picture. Just wait. Kinetic power is plus, which is correct. Right, but problem over here that kinetic energy is not a vector quantity. Now again, half over here doesn't play an important role. Mass is a scalar quantity and vector is velocity is a vector quantity, but it has a power with it, right? With a even power. Any negative number that has an even power becomes plus. Any negative number that has a like odd power becomes negative, right?
I overlooked the square. That's why.
Sorry?
I overlooked the
You overlook
square.
the square, right?
B
Okay,
square.
that's fine. Let me just write down this rule for you that any negative number with a power of maybe 2, which is an example for even number, the final result would be a plus. Any negative number with a power of 3, which is an example for odd numbers, all odd numbers, the final result would be minus. Right, so
I know I know this rule মানে আমি b স্কয়ারটা মানে স্কয়ারটা খেয়াল করিনি
that's fine. Then you know the final answer would be plus, right?
yeah
So what kind of quantity is scalar? Sorry, kinetic energy, it is a scalar quantity. So yeah, this is how you actually identify. Memorizing all the quantities, like if a certain quantity is scalar or vector, it's not that much an easy thing to do because in your A-levels A's, there's a lot to memorize, lot to understand. So I would not appreciate memorize these simple things which you can clearly do by simple calculations or understanding. So this is entirely the end for your topic one, which was physical quantities and units, right? So that's the end. And from next class, we'll start with the kinematics, speed, velocity, acceleration. So for the time being, this is not any fixed class. This was just a trial class. Anyone was free to join this class. If everyone wants to join the classes, then they can, like connect with me in WhatsApp or Facebook in whichever way they are connected to me with, and then confirm that if they want to continue the classes or not. So for the time being, we have 3 classes on Sunday, Tuesday, and Thursday from 8 a.m. to like 9:30. So 8 p.m. to 9:30 p.m. And there will be like one tutorial classes in every 2 weeks on like Thursday from 9 a.m. to 12 p.m. And every class recordings will be provided in the classroom and all. So yeah, that's it. If you have any problem, all the things that I explained in today's class, then if you have any problem from all the things in today's class, you can ask that out now. If you have any problem from all the things that I explained in today's class,
there's no problem
if there is no problem, then we will stop the class over here. Thank you for joining.